Hello, everybody. I'll briefly talk about our paper, Optimizing Traffic Control with Model-Based Learning, a Pessimistic Approach to Data-Efficient Policy Inference. Let me quickly define the problem. So I'll define it generically. We start with a static data set of the form state, action, reward, next state. This is typical in reinforcement learning. But the key difference is that we have this data set from the beginning, and our objective is to learn a policy pi, which is mapping from state to action in order to optimize or maximize a long-term reward. Once again, the key constraint is that we can only use the static data to learn the policy. We cannot interact with the environment, and we want to learn a policy which is ideally better than the one that was used to generate the data. So this might seem impossible, but that's what we will show. In the age of safe AI, offline RL will be a key component of decision making. So here's an example. So we have some cars crossing the intersection. The distribution of the cars is the state. Which light becomes red or green is the action we take. The reward is the number of cars that go through the intersection, and then the system transitions to a new state. So here's a more complex example, which is from a roundabout in Doha. And here what we have is, first we are collecting data from a cyclical policy. This is called the behavioral policy. So it's completely agnostic of the traffic. It just goes in a cyclical round-robin fashion from one light to the next and back to the first one. And after collecting the data, we learn a new policy, which we call ADAC. And this policy turns out to be not cyclical. It is more customized for the distribution of the data, and it turns out to be 30% better than the behavioral policy. The key principle underlying offline RL is called pessimism under uncertainty, and I hope you come to our poster to have a closer look at it. Thank you very much.